This lift was installed in 1926. For a human to reach 100 years old, I'm guessing you'd at least have a new knee. For this lift, everything's still original. There's lots of interesting devices, which I will explain in this video. There is a lot of history here because this place was started all the way back in 1780. This lift is still completely original from when it was installed in 1926. This includes doors, call buttons, such as this one, and the machinery which is on the roof. Firstly, this lift can be raised with the outer doors open to allow easy loading directly from the height of a delivery lorry. This explains why you can see into the lift shaft when the lift is level with the ground. The lift cab has 3 doors. The back and side doors are for internal access. Let's ride up to the top. And the first stop is to look at the lift machinery on the roof. This is classic vintage Schindler machinery. This looks like a derelict unit, but it's fully working. There's lots of old kit up here to go through. Let's have a look around, then I'll come back later and explain each component and what it does. Before we have a look at the machinery in action, we'll continue our tour at the lift cab. The lift can be moved up and down from the lever, which, as I mentioned before, can be done on the ground floor with the doors open. Or you have the conventional floor buttons above, which means you don't need to use the lever. The lift cannot normally be moved up and down from the upper floors with the doors open.
Okay.
Therefore, to film this footage, my camera is on the end of a tripod, held horizontally so that I don't need to go too near the open doors. The structure underneath the cab is similar to the floor supports of a building, but you have to remember that this design is from the 1920s.
Okay.
Now the lift motor room in action. And remember, afterwards I'll explain each device and how it works. Now to explain how this machinery works, and for that I'll start with placing a call. These relays link to the car floor selection panel and the landing call buttons. When a call is placed, the relevant floor relay activates and remains on. For this lift, no further calls can be placed until the lift arrives at its destination. The lift has to decide which direction to travel to reach that call. This is the direction logic wheel, which has switches on the inside, one representing each floor. There's also one on the outside that I'll come back to later. As it turns, the switches on the inside are moved left or right, depending on which way the lift is travelling. Before I explain this in a little more detail, let's mention the up-down handle, which doesn't need any logic. From inside the lift, it's easier to press the floor you want to travel to. Both were provided because on the ground floor, the handle can be used to move the lift upwards with the outer doors open to bring it level with a delivery lorry at the dock for easy unloading. The switches change the up-down logic for each floor. If the lift was on the second floor and a call is placed on any floor below the lift, a circuit is formed via these switches to the down direction, and any call above the lift, due to the position of those switches, the up direction is given. A voltage then goes to either this up or down relay here. The left relay is for down, the right relay is for up. A voltage is now sent to the brake release motor, which can turn in two directions. But without power, it's spring loaded to return to a middle neutral position which applies the brake. This brake motor turns the big wheel underneath. It will turn anti-clockwise if the lift is going down, and clockwise for up. Either direction will release the brake. The direction it turned is linked to these contacts on the other side. In the neutral position, you can see that all these switches are disconnected, and there's even more switches further back on each side. Therefore, the brake has to release and fully rotate before any of these switches are activated. These switches deliver power to the main lift motor, but depending on which way the brake turns, depends on which side activates. The left contacts make the lift go down, and the right side make it go up. So, a quick recap. The direction of travel comes from the logic switches. Then, the up-down relay, which is then linked to the direction the brake motor turns, to these contacts, which then send voltage to the main motor. And depending which side depends on up or down. Now the brake is released, and the main motor is moving the lift. But you cannot simply connect voltage to a motor that's not turning. Power must be applied gradually. This is called a slip ring motor. I have a separate video that goes through it in a little more detail. The middle of the motor, which is the spinning part, has electrical connections which are presented here. At this point, we can connect wires and bring them back to this caged area. Inside the cage are coils, which are actually high-powered resistors. The wires coming from the spinning part of the motor are connected to the resistors inside the cage. We can now vary the amount of grip that the motor gets when it's switched on. This is enough to turn the motor and represents a low energy startup. These massive contacts on the outside of the cage now gradually short circuit or bypass each set of resistors inside the cage. The timing is controlled by air. When the brake is released, this bar drops, leaving this one suspended, which is now under the control of this air chamber. As it drops, it turns this rotating cam. The cam then closes each of the switches. When all the switches are closed, all the resistors inside the cage are shorted out, which is now the high power state of the motor. Now the lift is moving. Let's look at this part. When the lift is between floors, this nut travels freely backwards and forwards. These are two stop ends, which represent the highest and lowest position of the lift car in the shaft. If there is a fault and the lift attempts to go beyond this, the nut will reach a stop end. Because it cannot travel any further, the rotation is now transferred to the outside of the unit. You can see that the mains power comes in from one side and out the other. Therefore, if the unit rotates, the mains power is immediately cut to the whole lift, and the lift stops where it is. Power is restored by using this handle. Now back to this switch on the outside of the wheel. This switch activates when the lift reaches the loading bay. Remember that the lift can be raised up to the height of a lorry with the doors open. Well, if you were to keep going, then it would expose the bottom of the lift shaft and people could fall into it.
Okay.
Therefore, if you move the lift too high, this switch turns off the up direction from the handle, until either you bring the lift back down or close the outer doors. And lastly, in the corner is an overspeed governor. Applies the brakes on the lift car if the lift goes too fast, such as if the chains were to break.
Yes.
I go to great lengths to make our videos detailed and as interesting to watch as possible. If you've enjoyed watching, please consider subscribing to the Mr. Matt and Mr. Chay channel, and thank you very much for watching.